Get started in about a minute. All right, here we go. Any questions on the homework? 13.1. Questions on the homework, 13.1. Okay, let's go over the answers. Number one, now they're getting sloppy and they don't put any units. Just remember, we should put the word units if there's no units. Distance is measured in units, not units squared or units cubed. Number one, the answer is 7. Number 2 is 5. Number 3 is 4. And number 4 is 5. Number 5 is root 10. Number 6 is 2 root 5. Number 7 is 10. And number 8 is 13. Number 9 is 2 root 13. Number 10 is a square root of 130. Number 11 is 5 root 2. And 12 is 4. Now on to the circles. All right, 17. Let's see. The center is at negative 3 comma 0. And the radius is 7. Number 18. The center is at negative 7, 8. And the radius is 6 over 5, 6/5. Number 19. Weird things, don't panic. Let's see. The center is at J comma negative 14. And the radius is the square root of 17. And number 20, let's see, the radius is negative A comma B, and the radius is C. Number 21, let's see the equation. The equation would be 64 is equal to, let's see, the quantity x minus 3 squared plus, if you put the quantity y plus 0 squared or y minus 0 squared, that's fine, or just y squared. Number 22, let's see, 36 would be equal to, if you put x squared plus y squared, that's fine. Or if you put the quantity x plus 0 squared plus the quantity y plus 0 squared, that's fine too. Number 23, just so you know, if there were ever zeros in there, we would absolutely positively leave them out. 23, let's see, 25 is equal to the quantity x plus 4 squared plus y plus 7 squared. And the last one, number 24, let's see, 1/9 is equal to the quantity x plus 2 squared plus the quantity y minus 5 squared. And that's everything. All right. You guys took your PSAT. I saw most of you yesterday. A couple people, I'm going to jump off this here for just a second so I can see who has not turned in their test. I want to say it was Ethan and was it one other, Brianna, where was the other one? People who had Seth. Yeah. Now, this is as of right now, this second. So let's see. Connor, Danny, your mom said you did the test, but I never got a picture of it. So I think you just didn't hit the submit button. Make sure you turn that in. We're talking about the chapter 12 test. Brianna, I got nothing from you. Ethan, I got nothing from you. Matt, I got nothing from you. Seth, I got nothing from you. And Chandler, I got nothing. With the exception of Danny, I put zeros in the grade book for all of you. Hey, get that turned in. Come on. The test was Friday was the test. It's Thursday. It's almost a week, and some of you have not taken your test. Out of the kindness of my heart, I'm going to allow you to turn that in. I should leave it as a 0. You don't wait a week to take a test. If this was a job, you would be fired. All right, enough of the stick here. Let's get back to learning some stuff. So here's the calendar. You took the PSAT yesterday. We're in 13.2 today. We'll do our last algebra review of the book tomorrow. And then we have 4 weeks left to the end of school. So notice that we will get through chapter 13, and that's about it. I will probably do one day of chapter 14, I think, and then we're right into semester final review. And then the last week, half-day schedules, Monday through Thursday are your finals. Friday is makeup day, and that's it for 2021 or school year 2020 to 2021. All right, here is your homework for tonight. All right, homework for tonight, page 532 to 533, 1 through 19, all. Here we go. Slope of the line. Yes, this is what you learned last year in Algebra 1. Remember, I was your algebra teacher, wasn't I? Or was it Miss Kittle? I forget. It was one of us. And last year we talked about slope of the line. Now, I did teach you pre-algebra. We also talked about this in pre-algebra. But at no time did I prove anything to you in those classes in Algebra 1. Right? I gave you a lot of formulas, never proved a single one. I said, trust me, this is the formula. Well, you're in geometry now. We prove everything. So basically, we're doing some cleanup of what you learned last year, which is basically things about the slope of a line. So everything I'm going to do today, I will prove to you to include the formulas for slopes. All right, it should be a review since the only thing I'm really doing is proving it to you. You should already remember or recall how to use these formulas. Well, we'll see. So we'll start off with the definition. This was the definition from 7th grade, where all we said was the slope is this word that describes the steepness of a line. So there's a line. Well, how steep that line is this thing that we call the slope. In 8th grade, we actually attached a value to it, a number, right? Slopes can be very steep, they can be not so steep, and they can be, well, I'm not sure how you describe that, opposite slope, right? If the first two from left to right there are steep slopes and not so steep slope, the other one goes in the other direction. Now, we've already dealt with this in pre-algebra and algebra 1, and we know what the slopes of these lines are. But I just wanted you to recall how we initially started our investigation about slope, which is simply to say it's just a number that describes how steep a line is. Quick note, we will be dealing not with curves, but with lines. And it turns out that the slope of a line never changes. How steep that line is, no matter where you look at the line, remember that line goes on forever, the red one, is always the same. The slope of it, how steep it is, doesn't change. Now, there are other things like curves. I'll draw one for you real quick. So if this is my XY plane, I could have a curve that where the slope changes multiple times, right? And then maybe it does something like this. So notice that anywhere along this point, the slope is different. It's always changing. For those of you going on to pre-calculus and calculus, you will deal with things like this, where the slope always changes. But for algebra 1 and for geometry, we deal with things where the slope stays the same. Algebra 2, you're going to start your investigation into some things that do change. When you do quadratic and cubic functions, those slopes constantly change. All right, so back to where we were at. We said that the number, or a slope is a number that describes the steepness of a line. In 8th grade and in Algebra 1, we had a more formal definition. This was the formal definition. We also call slope the variable m. It is lost to history why we chose, or not we, but why somebody chose to use the letter m for slope. There's a bunch of theories, but no one can pin it down specifically of why m was chosen. But that's the letter we use for slope. So m for slope, and we define slope as how are the y values changing over, it's a ratio, over how are the x values changing. And in other words, the change in y, how much is it growing up and down versus how much it's growing left and right, okay? Now, We further refined that, and we not maybe not refining. We said, well, how do most people do it? We always use this word rise over run. An interesting thing, you won't find this in most math books, but almost every single math teacher always says rise over run. So the rise is how much it's going up and down. The run is how much it's going left and right. Lastly, and then I'll stop with this defining. We also, in this one, you will see in most math books, they'll put the triangle symbol. There's no triangle there; it's a line. But the triangle also has a second meaning, and it means the word change. In science class, if you see a triangle, it's not a triangle; it's the word change. So, how is the y values changing over how the x? We also call that delta D. That is the letter D, Greek alphabet, the triangle. We call that delta y over delta x. Okay, so from this, what are you supposed to take from it? Just remember that slope is rise over run. That's the key. All right, so rise over run. So we also know that slopes can be a positive number, fraction, decimal, whatever. It can be positive. It also can be negative, and it also can be zero. We'll talk about a slope of zero in a little bit. Okay. Oh, well, there's a picture of it. It's horizontal line. I thought I waited until later to talk about it. Okay, so slope can be positive, negative, or zero. And now I got to do some proving things to you. All right. So I'm going to give you a line on a graph, and I'm going to ask you to calculate the slope. It's going to be the first thing they ask you to do tonight for homework, which is to calculate the slope. And since I probably taught you, I call this the monkey method. Why? Because I could probably teach a monkey how to do this. It's that simple. All right. So before I show you that method, I just want you to remember of what a lattice point is. A lattice point is, you see all the lines on the coordinate plane, like for instance, this line right here and this line right here. Where those two lines come together, they intersect. Where they intersect is called a lattice point. There's lots of lattice points on a coordinate plane. Anywhere two of these lines come together, hey, the origin is a lattice point. Anywhere that any two lines come together, intersect, is called a lattice point. So the monkey method for finding the slope of a line is look at your given line and find lattice points. Now, I've already found two for you, but there's other lattice points here. For instance, here is a lattice point. Here is another lattice point. Here is a lattice point. To calculate slope, you have to find lattice points. So lattice points are where the line, the red line there, intersects a lattice point. Okay. All right. So what do you do once you find? You got to find two of them. Then you simply calculate rise over run. How is that done? Now, I'm a creature of habit. I always go from left to right, but this also works right to left. I'll show you that here in a second. But I always go left to right. So if I go from blue dot to green dot, the blue dot's on the far left, the green dot's on the far right. And the rule is I must stay on a line. I must stay on a line. So if I stay on a line, well, I don't want to go down. If I go down, I'm never going to get to the green dot. But if I go up and then go right, I will eventually get to the green dot. So the rules are you stay on a line and you go from one dot to the other, counting tick marks or squares as you go along. So let's see, from the blue dot to the green dot, I would rise. Now rising, right, think of the y-axis, right? The positive numbers are above the origin, the negative numbers are below. So as I rise, I'm going in a positive direction. I'm simply counting lines. So let's see. I'll do this in red here. Let's count lines here. Let's count lines. If I count lines here, let's see, that's one line, two line, three line, four line, five lines, six lines. So I rose six lines. Now, if I had dropped six lines, I would put a -6. All right, so where am I at right now? I stopped right here. No, you don't need to put these dots. No, you don't need to put tick marks when you count the lines. So I'm right here now. I need to go to the right and think of the x-axis. If you go to the right, that's positive. If you go to the left, that's negative. Well, I'm going to count little lines again. So I'm going to count little lines again. Let's see. I'm right here on this red dot. So I would count 1, 2, 3. You don't count the one that you start on ever. So I went to the right 3. So that would be a positive 3. So my run would be 3. and we reduce the fraction. 6/3 turns into 2. So m, or the slope, is equal to 2. If you've never done this before, well, then you weren't paying any attention last year in Algebra 1, nor in 8th grade. I'm sorry, in 7th. Wait, you guys are in 10th grade. Nor in 8th grade when you took pre-algebra, right? You did this both in 8th grade and you did it in 9th grade. So I apologize for those of you who are like, I already remember how to do this one. Can you go faster? But I didn't want to do that one nice and slow, just so that we can say that we've done it once perfectly. By the way, there's nothing to prove here because it's a definition. We define slope as rise over run. That's a definition. Nothing to prove there. Notice my line here is now going in a downward direction from left to right. So I already know that the slope should be negative. I'm a creature of habit. I always go from left dot to right dot. So this time, let's see, if I go in an upward direction, I'm going in the wrong direction. I'm trying to go from blue dot to green dot. So I don't want to go up. I want to go in a downward direction. So I'm going to go down. Let's see, 1 line, 2 lines. Now I'm right here. I'm putting way more detail than I need to. And then I need to go, okay, let me catch up. So I went down 2. Down is in a negative direction. So let's see, that would be a rise of -2. And now I need to what? Go to the right. Right is in a positive direction. Don't count the one that you start on. Count the next one. 1, 2, 3, 4, 5, 6. So I went right 6. Right is positive. So that would be a positive 6. Reduce the fraction. That would be -1/3. All right. Anyone want to admit that they don't know how to do this? They've never done this. In fact, they slept through all of Algebra 1, and this is the first time they've ever paid attention. Anybody want to admit that? All right, hopefully it's none of you. Okay. All right, so that's how we calculate slope. One point I want to make, and I made it earlier, which is you don't have to always go from left dot to right dot. If I wanted to go in the other direction, let's say that I wanted to go from green dot to blue dot. Well, if I go from green dot to blue dot, well, I'm not going to go down 2. I'm going to go up 2. So my rise is 2. But my run is, well, I'm going to the left. Going to the left is negative. 1, 2, 3, 4, 5, 6. Oops, that didn't work out well. So I went left -6 squares or lines. But notice that -2/6 also reduces to -1/3. So it doesn't matter whether you go left to right or right to left, you get the same slope no matter which way you go. The only way you can mess this up is if you forget the direction that you're going. Remember, if you go up, that's positive. If you go down, it's negative. If you go to the right, that's positive. If you go to the left, that's negative. I always go left, not because it's better, right? I just creature of habit, left to right. All right, any questions on slope? I do need to point this out. If the teacher is nice to you, they already gave you lattice points. Look at, let's see, the first one right here and this one right here. Notice there's already lattice points there. The other two, there aren't lattice points. So you need to put lattice points, right? So in other words, just pick 2 lattice points. Hey, there's one there and there's one right there. On this one, let's see, there's a lattice point here. I'm picking any lattice point. And maybe I want to use this one right here. There's others. By the way, pro tip. If you pick the 2 closest lattice points, you'll have no reducing to do, right? Pick the 2 closest ones and you're good to go. All right. You pick the 2 farthest ones, you're going to have to reduce the fraction. All right. Let's just do these real quick. Let's see. The first one, well, let's see. I'm always going to go from left dot to right dot. So if I go from left dot to right dot, let's see, that would be, I have to drop straight down. So let's see, I would go down 1, 2, 3, and then to the right, 1, 2, 3, 4. So -3/4. If I'm going too quick, you got to speak up and ask questions. I'm going to assume, since you're not asking questions, that you understand this. All right, the bottom left one, once again, I got to pick lattice points. So I pick 2 lattice points and I simply count. You don't count the one that you start on. Let's see, I'm going up, 3 and then right 2. So that's a +3/2. It's okay that slope is a fraction. No big deal. You don't need to change it to a decimal. Upper right, I need 2 more lattice points. I'm going to pick some, well, let's not do this one. Let's pick ones that are far away. So I'm going to pick this one. I'll just show you what happens. All right, so let's see. To go from that one to this one, looks like we go down to, I'm going from left to right. So I'm right here, and then I go over 1, 2, 3, 4, 5, 6. So I get what? Negative 1/3. Notice I had to reduce because I did not pick the closest lattice points. Watch what happens when you actually pick the closest lattice points. So if I pick the closest lattice, that would be that one right there. It's down 1, right 3. So it's negative 1/3, no reducing necessary. So it's not that you can't pick any lattice point. You can, but if you pick ones that are far away from each other and there's closer ones as options, then you wind up having to reduce the fraction. All right, the last one, they already gave you the 2 lattice points. Notice there's closer ones, but it looks like I'm going, what, up 4, right 4? So 4, oh, that reduces to 1. But notice if I had instead chosen the closest lattice point, like that one and this one, it's up 1, right 1. Well, it's 1. Okay. So word to the wise, choose close lattice points and save yourself some time. All right, I'm going to stop right there and simply ask any questions. We got this? That's the monkey method, just simply counting squares. Monkey method worked great and all that, but remember the slope never changes for any line, so all I need is 2 points. The next, let me finish before I get to that one. So monkey method, we got it? There is one other method that I will teach, but in between that, I'm going to do one extra thing. Okay, so recall that the slope of a line never changes, never changes. If it's a line. If it's curved, that's not true. All right, so the second thing they're going to have you do for homework is going to have you draw a line. They're going to give you 2 pieces of information. They're going to give you 1 point that is on the line. It says 0.12 is on the line. And they're going to give you the slope of the line, and the slope never changes. So no matter where I'm at on the line, the slope will always be 3/5. You remember doing this last year in Algebra 1, where they gave you a point and the slope and asked you to draw the line? Well, how do you do that? Well, step number 1, graph the point. Well, there's 1, 2. Step number two is apply the slope to the point that you just drew. You see I drew the point 1, 2? Now I apply the slope. What does that mean? That means, well, slope is rise over run. So if the slope is 3/5, that means I'm going to rise 3 and run 5. Now both of those are positive. So that means go up 3, go right 5. Up 3, right 5. If one of those is negative, well, then change the directions. So I go up from the red dot right there. I'm going to go up 3 over 5. I wind up right there. Now, what if you wanted to go in the other direction? Well, if you want to go in the other direction, you write the opposite of the slope. Let's see, the opposite of both the numerator and denominator. I should say that more precisely. I need the opposite of both the numerator and the denominator. Well, the opposite of 3 is -3. The opposite of 5 is -5. And check it out. These two fractions are actually equal. 3/5 is the same as -3 over -5. Negative divided by negative is a positive. So why did I do that? Because I want to go in the other direction, right? Sometimes you just don't have enough space on your graph to graph another point, so you got to go in the opposite direction. So from the original dot, remember the original dot was 1, 2, I'm going to drop 3 and go left 5. And notice it makes a nice straight line. Nice straight line. We'll do this a couple times. Don't panic yet. All right, let's see that again. All right, so it says sketch the graph of the line that passes through 0, 5. That means the line goes through 0, 5 and has a slope of -2/3. Okay, well, graph 0, 5. Now be careful with that negative. When the slope is negative, that negative either goes to the 2 or it goes to the 3. It's your choice which one it goes to. So for instance, if I want to put the negative on the top, the negative divided by a positive is a negative, then from that original dot, I'm going to go down to right 3. You see that? I'm going to go down to right 3. If I want to go in the other direction, I write the opposite of both. The opposite of -2 is +2. The opposite of Positive 3 is negative 3. So from that original dot of 0, 5, this time I'm going to go up to left 3. Up to left 3. Let me show you that one more time. Graph the first point, 0, 5. When the slope is negative, you got to put that negative somewhere. Don't leave it in the middle, right? Either on the 2 or the 3, your choice. So as that slope appears right there, negative 2/3, that's down to right 3, down to right 3, down to right 3. If I want to go in the other direction, I write the opposite of the numerator and the denominator. Negative 2 turns to positive 2. Positive 3 turns to negative, because both of those equal negative 2/3. So from the original dot, now that second slope there, 2 over negative 3, I go up to left 3. Cool, straight line. One nice thing about doing 3-point, remember 2 points define a line. You only really need 2 points. But if you mess one of those points up, one nice thing about doing 3 points is that you'll immediately know. If you mess one of the points up or you apply the slope incorrectly, if you do it a third and put a third dot there, you get a V instead of a line. All right. Any questions on how to do this? Any questions on how to do this? All right, I'm going to pause for about a minute, let you get started on these, and then I'll walk you through each one. All right, first one on the left, let's see, it passes through 3, 4, and it's a slope of a half. So passes through 3, 4, so there's 3, comma 4. Slope is up 1, right 2, up 1, right 2. Or if we go in the other direction, down 1, left 2. Play connect the dots. Hey, nice straight line. This one right here, let's see, it goes through negative 2, 2. I know I did this one backwards. I remember this doing it the other day, and the animation is just out of order here. All right, actually, let me fix that, and then life will be grand. I need to do 5. Negative 2, 2, so 7 needs to come before is the first one. There we go. All right. So negative 2, 2, there we go. And then the slope of 3, well, let's see, how do you turn 3 into a slope? Because there's only one number, and I need rise over run. Well, just put it over 1. So 3 over 1 or negative 3 over, I'm writing the opposite of each one. So there's your slope. If we want to go in the upward direction, we go up 3 over 1. We want to go in the downward direction. Let's see. That would be down 3, 1, 2, 3 over 1, and put a dot. You want to continue, or in the other direction, up 3 over 1, there's another dot. Play connect the dots, and there you go. Ooh, we like the origin. It passed through 0, 0. So it passes through 0, 0. Remember that negative 2/3. The negative's got to go somewhere. So you put the negative on the top, or you put the negative on the bottom. Your choice. There's my 2 slopes. One goes up left, and one goes down right. Regardless of which one you choose, right, we still wind up with those dots. So it goes through 0, 0, and then I'm going to choose to the first slope there, down 2, right 3, and I did it twice. If I want to go in the other direction, that would be the second slope here. So from the origin, that would be go up 2, 1, 2, 3, left 3. Okay. Any of those work. You don't need to do 4 points, right? My dot was way off there. That's horrible. There, make a nice big dot, and then it looks right. Okay. Any questions on what we just did there? Any questions on what we just did there? Not too challenging, right? All right, we finally arrived At the very next thing, which is, what do we notice about the slopes? Well, the slopes that go up from left to right, are positive. The slopes that go down from left to right are negative. All right. Now we're going to do this entire process, except we're not going to graph. We're just going to do a calculation. In other words, I'm going to ask, what is the slope between 2 points on a line? But we're not going to graph it using the monkey method. We're going to use a formula. So as always, I can't just say, here's the formula. I got to prove it. So let's prove this sucker. All right. This is called deriving a formula. Deriving a formula. When you derive a formula, that is where we use some logic, aka the proof, and we eventually arrive at the formula. All right, so let's see what that would look like. We've defined slope as the steepness of a line, rise over run. Great. I'm going to draw a coordinate plane. There's my coordinate plane. O is origin there. And I'm going to put a line somewhere on the graph. I am not claiming that that red line is where it is. I'm just claiming that the red line is somewhere on the graph. Okay, that way that this will be true for any line anywhere on the coordinate plane. So even though, yes, I did draw it in quadrant 4 and quadrant 1, I'm just going to claim that that line is somewhere on the coordinate plane. Let's see, monkey method, I need 2 points. So I'm going to pick 2 lattice points. Well, there's no lattice there to make lattice points, but I'm going to claim they are. All right, so I need coordinates for those 2 points. And most of you at this point would be saying, how could you get numbers for those if there's no numbers involved? And I agree, so we're going to put variables. So my first point, the point there on the left, I'm just going to call it x1, y1. My second point, well, if I call the first one x1, y1, my second point I'm going to say is x2, y2. Okay? I'm going to do the same thing as that proof I did with the distance formula when I derived that one, which is from point x1, y1, I'm just going to draw a dotted line horizontal. Well, it's horizontal. From the point x2, y2, I'm going to drop a vertical down to that other the other horizontal line and make a right triangle. Now, it's not important that we make a right triangle here. It just so happens I made a right triangle. Where those 2 dotted lines intersect, I'm going to boldly claim that that's x2, y1. Now, where in the world am I getting that from? Well, let's think about this. Think about this for a second. Let's see. Well, the first thing I'm claiming is that the x coordinate is x sub 2. Well, I'm claiming that this one is also x. How could that possibly be true? Because remember, any point on this that's a horrible vertical line. Any point on the vertical line right here, any point on that vertical line would have the same x value, right? It literally goes through the x-axis at one point, this point right here, and let's just say that that's 10, then any point on that blue line would have the value 10. So that is why I'm able to claim that the x value of that where the 2 dotted lines intersect is x sub 2. By the same logic, that's why that value is y sub 1. Notice on the horizontal line that goes from x1, y1 to x2, y1, notice any point on that horizontal line, any point on the horizontal line, this dotted one right here, has the same y value. Why? Pun intended. Why? Because it goes to the same y value. And if that y value right there was 10, then any point along that dotted line right there would have a y value of 10, which is why, pun intended, I can claim that the y value is y sub 1. Okay, great. Now I have 3 points. I'm not sure where I'm going with this. I'm going to borrow from the distance formula, right? The distance formula, if you remember how I introduced it to you, I said that any horizontal line, or horizontal segment, sorry, how do you find its value, its distance? We take the 2 x values and you subtract them. Now, I did say take the absolute values, so let's think about this. If x sub 2 is to the right of x sub 1, well, then it's always going to be bigger. So I don't need absolute values for that one. Think about that. If x sub 2 is to the right of x sub 1, and it is, then when you subtract them, you will always get a positive number. A big number minus a small number is always going to be positive. Okay. Let's see. We'll do the same thing with the y values, right? So for the y values, all I'm going to do is take y sub 2 and subtract y sub 1. Well, that's pretty cool. Because why? Because I defined slope as rise over run, and we just figured out that the rise was y2 minus y1, and we just figured out that the run was x2 minus x1. And that, ladies and gentlemen, is why last year, when you wrote down the formula for slope, that's what you wrote down. You wrote down the formula that m, and this needs to go in your notes, that m, or the word slope, is equal to y2 minus y1 over x2 minus x1. So everything on this slide, you don't need to write down, but what you do need to write down is what I'm circling in blue. This is the formula for slope. And I'll give you a second or two to copy that down. That's the formula for slope, and we just proved it. For those of you that are still wondering about the why is it positive for the distance, well, let's just take the weirdest case where this is all in quadrant, I don't know, where everything's negative, quadrant 4, right? So if we're in quadrant, if we're in quadrant 4, and we have a line somewhere in quadrant 4 right here, and let's just throw some random numbers here. Let's say that the x value of that point is -2, and the x value of this point here is -7. So if we do -2 minus -7, notice we get a positive number. That's probably the only one that some people might say, well, you need absolute value. No, you don't, because if you do the right dot minus the left dot, you always get a positive value. The same thing for the y values, as long as you choose the one that's above. Okay. All right, so I'm going to erase all that scribble, and we will look at some applications of this. All right, so the application of this, I'm going to give you a visual one of this, and then we'll do one with just the values for the points. All right, so visually, let's see. I got 2 points here, 5, 4, and 3, -1. It says calculate the slope of the line. Step number 1 is, well, we apply the formula, y2 minus y1 over x2 minus x1. So I write the base formula. Step number 2 is I got a label. Labeling is really important. It doesn't matter which one is 0.1 or 0.2. You're always going to get a positive value. I just showed you that, right? You're always going to get a positive value. So I label the first point, whichever one you want to choose, is your x1, y1. Not x1, x2, but x1, y1. Your second point is your x2, y2. Now we simply plug and chug. We just simply take those values, plug them into the formula. Let's see. The formula says we need y2. Y2 is -1. And there's a subtraction symbol. And then we need y1. Y1 is 4. All right, enough of those pretty colors. Let's plug the numbers in. So we get -1 minus 4. Why is it minus? Well, the formula has a minus in it, right? Can you see that in the formula? Has a minus sign. We do the same thing with the x values. The x values. So I need x2. x2 is 3 and x1 is 5. So 3 minus 5. Do that math. Negative divided by negative is a positive, so we get 5 over 2. There you go. Calculated the slope without a graph. You're like, well, yeah, I had a graph right here. Well, I'm just showing you that. Notice we can visually tell it's got a positive slope, right? Yes, you can do this whole process without a graph. And in fact, that's what you will be doing tonight for homework. They will just give you the 2 points and ask you to calculate the slope. But one more time with a graph. Doesn't matter which one is 0.1, 0.2. It is your choice. All right. But once you make that choice, the first one is x1, y1, not x1, x2, but x1, y1. Your second point is x2, y2. Is everybody okay? Are you tracking? Okay. Plug and chug, plug and chug. Be careful with the plug and chug. Y2 is 2 minus y1 is 5. So 2 minus 5 over x2 is 7 minus minus 2. You see where those two negatives came from? X2 was 7. The formula has a minus in it. And x1 is a -2. So therefore, you get those two negatives. Two negatives turn into a positive. 7 plus 2 is 9. 2 minus 5, -3. Reduce that fraction, -1/3. And you can tell from the graph, look, the slope is negative. As I stated, this is not new. What's new is the fact that I proved the formula for you, right? Last year, I just simply said, hey, trust me, look at this formula, it works. And then I just proved it to you. All right, we okay, everyone? All right, remember, positive slopes, negative slopes look like that. The last thing we will talk about are these two right here, the vertical and the horizontal line. The vertical and the horizontal line. Last year I made a big deal about this, and you probably had it memorized last year. And now you've probably forgotten this, but let's recall. What are the slopes of vertical and horizontal lines? Somewhere in your notes, make sure you put this. All right, I'll just toss in some numbers here and we'll do the calculation. We know that on a vertical line, what doesn't change are your x values. Your x values are always the same. So that when you do for the vertical line, when you do the math, well, the x values are exactly the same. You get 0. Doesn't matter what the y values are. The y values will be different, but the x values will be exactly the same. So if it's 5, 5 minus 5, you get a 0 in the denominator. You can't have that. You can't divide by 0. Therefore, all vertical lines do not have a slope. We'd say no slope. That is different for horizontal lines. Horizontal lines, the thing that doesn't change is your y values, So what doesn't change are your y values. For instance, if the y value here for both of these dots were 5, a positive 5, when you did rise over run, you'd get a 0 in the numerator. And that's perfectly fine. When 0 is in the numerator, 0 divided by anything is 0, which is why the slope of a all horizontal line is 0. So what do you need in your notes? You need the word vertical line and the word no slope or undefined. Some books will write undefined. Be careful, no slope sometimes get confused because no value might mean 0, right? But we're going to say that no slope is undefined. Horizontal lines do have a slope. It's 0. 0 is a number. It's not that they don't have no slope. That's too many negatives there. No slopes. It's just that the vertical line, it's undefined, but horizontal line, the slope is 0. Hopefully you're not confused, and I hope that's not the first time you've ever seen it. If I taught you, well, you've seen it before. Yeah, you guys had Miss Kittle last year. That's right. Finally dawned on me. You had Miss Kittle. But she taught the same thing I taught. In fact, she used my slides last year, so I know that she went over this with you. All right, why is this a good thing? Well, if they give you a vertical line, you don't need to do any calculation. You write no slope. They give you a horizontal line, there's no calculation necessary. You just put the slope is 0. If it's a diagonal line of any sort, then you got to apply the formula. Okay, well, that's literally it. And what do I got? 5 minutes left. We can look at a couple of these. All right, so tonight for homework, they're either going to give you a graph with 2 points listed, or they will just give you the 2 points. Well, we can tell that slope number 1 has a positive slope. Slope number 3 here is negative. And look at the middle one, slope number 2. It's a horizontal line. And from the previous slide, we already know the slope. We don't need to do any calculation. The slope is 0. For question 1 and 3, though, you will have to plug it into y2 minus y1 over x2 minus x1. All right. Tell whether each expression is positive or negative on the line shown below. So let's see. Well, we can certainly tell that number 4, it's got a positive, and number 5, it has a negative slope, right? Pretty easy to tell right there. And then if they just simply draw a picture, they're just asking you, some of the homework will be like this, but most of it's not. These are just the classroom exercises. So A is positive, B is undefined or no slope, C is negative, and D is 0. All right, it might give you some weird ones right here. Notice, find the tangent of N. Well, remember, tangent, SOHCAHTOA, was opposite over adjacent. Well, I need values for that. So in other words, they're asking you, what's this distance right here? And what's this distance right here? They are asking you the distance formula. But wait a minute. In order to use the distance formula, we need to know this point right here. Well, we can figure that out. Remember, any line on the vertical line here from B has the same x values. So I know that we'll call this point C. we know that its x value must also be 3. We also know that its y value, well, it's on the origin or on the x-axis, its y value must be 0. So I believe there's a couple homeworks tonight where they ask you both the slope and the distance of something. So you may have to use the distance formula. Remember, just so you recall, d for distance, this is the previous night's homework, is equal to the square root, big long square root of x2 minus or plus. Do you remember? Yeah, it's minus. Minus x1 kind of looks like the slope formula, but then there's a plus symbol. And there's also a squared. And then what? Y2 minus y1. That's the distance formula. Oh, I so need a tablet and a pen. All right, so you'd have to do both the slope of AB. That's easy to figure out. But to find the tangent, you would have to find the two distances of AC and BC. Okay, I'm going to stop it right there for today. If there's any questions while you're doing the homework, send me a chat. For the people that I called out earlier that did not turn in your test, you got to turn in your test. Stop being lazy. It's been a week, right? Get your test turned in. Yes, you should never end on a negative note. So have a great day, and I will see you guys tomorrow.